I'm happy to take a crack at that. So I'm Allison. I lead product for Joby Aviation. At Joby, we're a vertically integrated company. And so we actually take that very seriously. And so we think a lot about how do you design and build all of the parts of the ecosystem necessary to bring urban air mobility to life, to bring air taxis to the market in an efficient and timely fashion. So to us, we like to call them Skyports, for one, because one of our partners that we announced in Dubai in the last couple months is Skyport's the company. And so they are actually building this infrastructure, this vertiport infrastructure in Dubai as part of that offering there. But we think a lot about what do these physical infrastructure pieces need to look like, and how do they operate in a way that actually adds value to what people need to use urban air mobility for. And so we actually have built, in partnership actually with Skyports, we've built kind of a demonstration terminals that we actually have used to do studies with different populations of people that we bring in and look at, take videos, photographs of how they move through this terminal in a way that is as seamless as possible. And I think that's really the way that we want to think about this new type of infrastructure. It is infrastructure that reduces or smooths over the seams between the different modes of transportation. We don't want people to have to stay and spend lots of time in this infrastructure, because that robs you of the whole point of urban air mobility, which is to get you where you want to go faster and better than you can go on the ground or on any other mode. So we actually have to design the infrastructure thoughtfully so that people can move very cleanly through it and use software to actually enhance that experience, so that we're linking the software that's powering the operation to moving people through this infrastructure in a way that you basically ideally never stop moving. You get out of the ground mobility option, maybe it's a self-driving car, maybe it's a bike or scooter, you walk into the Skyport and you just never stop moving until you're on the aircraft and then you fly away. That's our ideal, and that's what we're striving to design this type of infrastructure to enable.
Fascinating to imagine as well what the future is going to look like as well. Jürgen, over to you from an aircraft perspective as well, of course, from FlyNow Aviation. What else do we need to think about? Obviously, you mentioned safety and a seamless experience as well. So tell us a little bit more about the considerations such as handling and landing and takeoff. What in your mind are the biggest concerns?
So as we saw, there's a lot of different companies out there working on very different kind of concepts. There's smaller ones, there's larger ones. And these vertiports should be able to be used by all of these different types of aircraft, how to store them, how to charge them. So I think that, depending on the volume, and not every vertiport is going to have the same frequency. There's going to be smaller ones, there's going to be larger ones, so there has to be a certain modularity. There has to be the infrastructure for charging them and maintaining them. There will be the larger ones, which there's also going to be storage and service. And then there's smaller ones where there's only, starting and landing. So there has to be a flexibility to meet the requirements specific to the location where these vertiports are going to be built.
So we heard a little bit about Joby. Tell us a little bit more about FlyNow Aviation as well, in brief.
FlyNow Aviation is a company from Austria, and we are working on a family of vertical takeoff and landing aircraft for 1 and 2 persons and cargo up to 200 kilogram. The reason why we are concentrating on 1 and 2 seater is because 9 out of 10 cars is only 1 person sitting in it, and we are actually trying to substitute ground-based traffic done by cars. So we are pretty much on the other end of the scope as, for example, Joby is.
Very exciting. And we can see both of your models here at the event today. That's right, yeah.
Yes, just at the entrance there is our booth. We're standing at Bayanat.
Brilliant. And Joby, you're just around the corner as well, aren't you?
Yeah, it is about 15 meters away.
Yeah. Brilliant. Okie dokes. Right, Paolo, over to you. Now, you are more focused on the design process and certification, which is correct, right? So, vertiports are going to be built in sort of highly populated areas. So what does this mean for a company that needs to design and certify these types of advanced air vehicles as well?
Yeah, so first of all, let me say 2 words about Altair, because it's a company that is very well known in the small area of automotive and aerospace, but maybe not the general public. So we are one of the key leaders delivering simulation and data analytics all together to build digital twin. That means basically, in few words, that we can create a virtual laboratory where you can test a product that does not exist today. So it's still virtual. And through that, you can also do some of the testing that are required for certification. For instance, thinking about advanced air mobility vehicle. One of the key points is that it must be safe, of course, as everything that fly. But on top of that, there is also the point of social acceptance. So you can actually, through simulation, show people things that they cannot see. Like, for instance, what is happening in case of a bird strike to the structure of the airplane. And with these things simulated, you can save a lot of money in physical testing that you do just at the end when you are sure that the aircraft is ready to face this test. Another key point is noise. So when you think about urban air mobility in the future, you have to think about maybe a few hundreds of these vehicles that are flying over a city. So if you don't control noise today when you design the airplane, you can have some big problems in the future. Again, even for the public acceptance. So all of this is something that today is done through digital engineering and simulation, and can help a lot in designing something that can fly over cities.
So Eric, speaking of the design and the architectural, operational considerations we've got to think about as well, what do we need to do when designing aircraft to sort of match that infrastructure? And I'm presuming, as you mentioned, a vertiport, a Skyport isn't going to be the same. It's not a one-size-fits-all. So how do we sort of bridge that gap? Yeah,
so we've actually worked with the FAA. Toward the end of last year, we did a series of tests with the FAA that we published some video of those flight tests actually, where we looked at the precision landing capabilities of our aircraft and actually then shared that data with the FAA relative to other types of aircraft, like helicopters, for example, and showed that this, at least for the Joby aircraft, the control capabilities of this aircraft are such that you can land very, very precisely. And so you really don't need anything more than what is already prescribed in terms of heliport kind of like size and mass structural considerations to support this type of an aircraft. So that's a really important consideration, and we've actually talked about this in a number of different forums, that we think it's actually pretty key that we don't burden the requirements on new vertiport infrastructure with something beyond what's already existing for helicopters, because these vehicles are very performative. The second thing that's an important consideration is that we've actually started to do a lot of work on how do you design the kind of essentially modular takeoff and landing locations with integrated ground service equipment. So we published an open specification on the charging work that we've been doing that has essentially a different approach to charging that can charge multiple batteries that are independent simultaneously and actually condition in a coupled way. So thermally condition the batteries in a coupled way as you charge them. This makes a really big difference in terms of the life of the batteries, which then makes the operating economics of the vehicle work much better. So we're actually have published that as an open specification. We're working it through standards bodies now as well. And we are actually now working on the design of essentially modular takeoff and landing locations with that same charging equipment built into that. So we can effectively deploy these as modules retrofit onto existing structures, stand alone in different ways that actually then can very rapidly be deployed. Because if you want to have a lot of takeoff and landing areas, which is what we all want, because people would need to go from where they are to where they want to go, right? And you want to take off as close to where you are as possible and land as close to where you want to go as possible in order to save the most time, because flying through the air is the fastest thing. So in order to do that, you've got to deploy a lot of this infrastructure. But to deploy a lot of infrastructure, it can't be cost prohibitive. So we think it's really important we do thoughtful design up front of how do you build this type of modular infrastructure with integrated ground support equipment so that you can deploy it rapidly and actually start to scale out this service in a way that is cost effective, not cost prohibitive.
Yeah, thank you so much. So much to think about, of course, in the design process and aligning everything and making sure there's a seamless experience. Jürgen, that was something I wanted to ask you about as well, in terms of the batteries and the storage. How do we make sure, when it comes to architectural and operational considerations in design, what in your mind needs to be taken into account as well?
Yeah, I fully agree that standardization is very important. We are working with EuroCAE about the standardization processes. And there is another mobility industry where there is a lot of experience concerning charging with, batteries, which is the automotive industry. And they have been struggling for about 10 years of, what the actual technology for charging is, what the plugs look like, and so on. And in Europe, they realized that, they don't have to reinvent the wheel, but to actually stick to existing regulations and standardizations and also charging infrastructure. Not only on the vehicle side, but also on the stationary side. The bigger the aircraft, usually, the more power they need, the bigger the batteries are, the more power you need to charge them. And then, of course, you have to consider all the safety necessary. And there you can, copy a lot which has been learned in the automotive industry. So we have a close relationship also into the automotive industry, into the charging infrastructure, which they have built up the last 15 to 20 years. As I said, reinvent the wheel, but really right to use this, because charging stations for cars, take up to 300 kilowatt for one car. And if you want to then that's a very good way to go.
Yeah. Paolo, what in your mind are the other complexities that we need to address? Is there anything keeping you up at night that still needs to be figured out?
Well, if we think about vertiports, he was actually touching a very important point, because you have to think about a very, very complex structure where you have to bring a lot of electrical power if you want to quickly recharge eVTOL's aircraft. So we are talking about even thousands of kilowatt per hour. So this is a big challenge from the safety reason. It is a big challenge because you need to produce this energy and move this energy from the production site to where it's used. So you have cables, you have electromagnetic interference that are everywhere. On top of that, you have a structure that will have several of these aircraft landing on that. So you have to look also at the structural integrity. What is happening in case of fire? So it's a pretty complex environment that, by the way, is also regulated by several different entities. You have the fire brigades, you have the city council, you have people that are taking care of thousands of different permissions. So this is where the complexity is. Simulation is, of course, helping with, again, analysis. The data analytics side is able to bring into the picture a lot of insight from sensors, from historical data, and so on, so you can have a better picture. You can add artificial intelligence to try to have quickly some insight from this data. That it's still I would say a big problem that is getting bigger if you move the vertical inside the city.
We haven't spoken about air traffic management, which of course is something we must talk about because it sounds like it could be quite hectic. So what sort of innovations in air traffic management systems do we need to take into account as well, do you think? And what in your mind is maybe a worry or an opportunity in that respect, Eric?
So we've been pretty careful to design our aircraft to fit, talking in the US context to start with anyway, to fit within the existing air traffic system with no changes needed. And I think that's a really important consideration because when our aircraft is certified and the pilots are rated to fly it, it will be just like any other small aircraft in the system right now. And that will support the initial rollout of operations. And then there's some things that we can do. We actually have started to work with NASA on some simulation studies. We've published one last year to show that with very small additional procedures introduced into the existing system, you can actually handle capacity in a relatively complex airspace. This is the Dallas-Fort Worth DFW Metroplex was the place where we did this simulated study on the air traffic there, that you can actually get a surprising number of operations per hour into the central terminal area of that type of an airport with, again, relatively small additional procedures being added that were actually taken from other airports in the US that are already using those procedures for helicopters. So this was a pretty eye-opening thing we did. We used retired controllers in a full-blown simulation that was actually run by NASA in their air traffic control simulation center at NASA Ames in California. And it was pretty exciting to see the result of that. It was a culmination of 5+ years of work across multiple different companies that my team actually was at and stuck together now is at Joby doing this work to really push, I think, the thinking forward across the board on this. Now, ultimately, I think then what we see happening down the road is that there will be like incrementally additional procedures and changes in the system. And when we get to full autonomy for aircraft like this, which I think it's going to be a little bit before we get there, I think you then see more changes being required to handle that in the system. But we don't need that to get going. We can get going day one existing system.
And I suppose you've got to evolve as the technology evolves. So that's another consideration as well, because technology is evolving all the time. So what do you think you have to consider in that respect to make sure that everything is aligned with the evolution of innovation and technology?
Well, as Mr. Allison said, trying to stick with existing regulations is a good way to start. Mm-hmm. But on the other hand, of course, and that's the reason why we are here also as a partner with Bayanat, looking at the digital twin, because if we really want to make a change, we are talking of hundreds or even thousands of aircraft, and therefore the airspace in the low altitude has to be regulated differently. So it's very good to have a digital twin and all the information necessary to handle this amount of aircraft. On the one hand, on the other, it's also about the vertiports. They have to be able to handle a lot more aircraft at a much shorter time than what we are used to. Yeah. So processes are extremely important. Also for the ground handling crew, the better the process, the fewer people you need for the same amount of aircraft. And this is extremely important because we also want to get the landing fees down, right? Because if you look at the landing fees you have now at heliports, for example, they are not acceptable if you actually want to bring, 5-10% of the people of the ground-based traffic into the air. You really have to reduce the cost in every aspect. And the landing fees, of course, are making quite a large amount in a business case.
Well, Paolo, it seems that digitalization has very much been highlighted as a possible solution to a lot of these problems. So you are obviously a global player when it comes to this, and when it comes to the digitalization of engineering and things as well. So where are we when it comes to the digitalization of the industry, and what else needs to be done, and why is it the solution?
Well, the fact that digitalization is super important is clear to everybody. Everyone is using simulation, anyone is using data analytics, anyone is building digital twins. The point in the industry is that let's say traditional players are very cautious, It's a heavy regulated, heavy safety critical industry. So there are so many things that they look at to be sure that everything is okay, that usually they are also slow in doing that. And they are slow also because they don't want to take any risk. The nice thing about working with startups, and we are doing that a lot, is that startup or new players, because I don't consider Joby a startup anymore since a while.
We're a big startup.
But it's really to see how much they are into digitalization, how much they are trying to understand and use at the best these new technologies to accelerate their journey, cut costs, and create something that is as safe or even safer than the generation before, but in a revolutionary way. So I would say that thanks to this new movement of startup innovators, we are on the right track to bring digitalization in the industry.
With my last question, I wanted to throw out this to the audience. Please make sure you get a good question going. This is your one opportunity to ask any questions. I'm going to ask one last question to each of them, and then I'm going to throw to you. So please, yeah, if we could get a microphone ready. Building trust. We've spoken about trust very much in the morning. We had a session just before as well. How do we build trust? Because even myself, I'd be a bit skeptical, and you worry because it's new technology and you don't understand it. So how do we manage trust? Maybe each of you could give us your take on that.
Well, I think that the key is what you just said. It's building trust, and you don't build something overnight necessarily, unless it's one of these booths, and then maybe you can build it overnight. But it's a process, and so things like showing the aircraft and the other things that we're showing here is part of that trust building process. We did a demonstration flight in New York City back in November, I believe it was, off of the downtown heliport. And that is a baby step in terms of building trust with the communities. You get people to see it, be able to hear it. I can't tell you how many people were like, oh my gosh, I saw this thing flying out of my window. And were you guys flying in New York? And it's things like that start to socialize, start to build trust. And you'll see us doing more and more of these things over time as we march toward a commercial launch. And when we launch, we're not going to start with, it'll be relatively small. It's going to be a crawl, walk, run approach that we'll launch with a handful of aircraft initially, and then we'll scale up from there. And we'll be building trust along the way as we demonstrate the utility and the safety and the performance and the experience of the service that we'll be offering.
Very well said. Jürgen, over to you.
Yeah. As I said in the very beginning, we are having a single and a twin-seater and also a cargo version, which will be the first going into commercial application. And by cargo, everybody can see that the systems work, really setting it up with all the necessary stakeholders for the full infrastructure, not only on the private side, but also on the public side, working together with the aviation authorities. Everybody first, the trust has to be within the community so that they actually know how it works, and where are the pain points and what is to improve. And on the other hand, of course, the people, the bystanders, first just seeing this, observing it in the beginning, just what people usually do, they don't try it themselves, they just take a look. So, and if they see then that, there is that many cargo flights happening every day, and they see, okay, that's safe, then the next thing is, well, if they can fly cargo, why can I use it?
Yeah, true.
And then that's naturally the next step. So not trying to keep pushing the people, but to have actually a pull factor and getting the people doing this themselves. And it's very interesting talking to the people here because they are very open-minded. They have a very high affinity to technology. Most of them I would consider innovators and early adopters, which of course, just like with the implementation of electric cars, these are the first customers, right? And we think that about 10% of these people are going to be the first which going to try it. So we're talking about 1 to 2% of the people in the beginning. That doesn't sound much, but if you think, 1% out of 1 million is already 10,000 people. And that's quite a lot. If these 10,000 people go to work in the morning and in the evening, that's 20,000 flights, right? And that means that's a lot of aircraft. And then you can do the calculation, the math, and you'll see that very quickly this is going, to really spread. And last month I was at LEAP at Riyadh, and I was talking to a Riyadhi, and he was telling me, 5 years ago they opened, driving cars for women.
Okay.
And it took women about half a year. First it was only a few, and then all the neighbors saw, well, she's driving, so let's try it yourself. And it took the women half a year, and then all of them started to drive cars. And that's quite a good example, I think, of how this is going to work also in 3D mobility. First, everybody will be skeptical. To break the first barrier, we think that cargo is a very good solution. And once people realize, okay, they can deliver my pizza, so probably I can try it myself. And then this is going to grow and following the Kondratiev cycle, just like every other technology.
So it's a mix of curiosity, convenience, and speed, I suppose.
Yeah, once they realize, it's safer, it's more comfortable, you're going to be on time.
Yeah.
You're producing less noise, you're needing less resources on the vehicle side as well as on the infrastructure side. And it's available and affordable to pretty much everyone.
Perfect.
There is no reason why not to use it.
Paolo, your final words, and then we're going to throw out to our audience if there are any questions. Yeah. Yes, please. Go ahead.
I think that trust is coming also from knowledge. Just as an example, a few years ago, I was asking a lot of people, would you fly on a full autonomous aircraft? And the answer was no, never, for most of the people. And then you start saying something like, do you know that when you board on an aircraft from London to New York, probably the pilot is touching the joystick for something like 10 minutes, and everything else, of course, is supervised, but is fully automated. So people start thinking about the fact that there is a technology in place that is proven and it's working. So we are in an industry that it's really pushing hard on safety, on demonstration of what are the capabilities of technology. It's true that now we are accelerating the way in which we are bringing new technology inside the industry, but this does not mean that we are not going into staying on the safe side. And knowledge or showing, as they said before, that these technology are proven, they are working well, that they are tested. Also the idea, I go back to my field, that is simulation. Today you can run, thanks to high performance computing, thousands of tests that you were unable to do before. You can reuse data that are coming from 10, 20, 30 years of experience to feed a digital twin model in order to build quickly the knowledge that you need to move forward with your testing. So we are at the point where technology is really helping to make the aviation safer. And this is something that is also becoming visible to people because, for instance, through simulation, you can actually see what is happening when a bird is striking your wing, or a bolt is hitting your aircraft, or what is happening in a case of a hard landing.
Thank you so much. I did promise our audience one question. Do we have a question? Did you have a question earlier? Yes. So the gentleman just here, we have run out of time, but let's give this question a go. Nice to get a bit of audience interaction, see what you guys think.
Thank you. Just I have a question. What could be the impact of looking into hybrid technologies? So hybrid integration, utilizing hydrogen, for example, with EV. So what do you think on that? Do you think that maybe we look into so much of intensive infrastructure setup to focus on the EV and electric charging while in the future we might consider some, or there might be technological development into hydrogen and the different ways of charging that can gap maybe a couple of current gaps in EV or in energy system?
Great question. Please do go ahead.
So we actually, in 2021, we purchased a company based in Germany called H2Fly. We didn't publicize it a lot at the time. It came out a couple of years later. H2Fly is building basically hydrogen electric fuel cell systems. They flew the world's first piloted aircraft that was fueled by cryogenic hydrogen last year. We think there's a lot of potential for that approach in aviation. Hydrogen is kind of an ideal aviation fuel in some ways, that it is incredibly light for the energy that it contains, and in aviation, weight is everything. Volume is also important though, and unfortunately hydrogen is also very low volume, or very high volume for its given weight, so it's low density. But I think that there's really interesting design things that you can do to address that, and so we're very bullish on the hydrogen electric next step in some sense. I like to think of the work that we're doing with all electric aviation right now as this first stepping stone of a really fundamentally disruptive innovation. If you think of the result of when that aircraft that's just across the way is certified, we will have certified batteries, we'll have certified flight electronics, electromechanical actuators, fly-by-wire systems that integrate all this together, that and of course world-class electric motors that are all kind of now a certified platform in some sense. And adding a new technology around energy storage is the incremental work is far less than the initial work. And so I think that there's a natural progression of this technology over time that then expands to other form factors and to other missions for aircraft, where hydrogen is almost certainly the right answer for that.
We have run out of time, but if you'd like to add something very quickly, you may.
Well, think about it from a really very high perspective. 200 years ago we had horses eating hay. So the energy carrier was hay and the energy converter was the horse. 600 kilogram for 1 horsepower, pretty bad weight to power ratio. Then came coal and the steam engine, and the steam engine came the trains. Then came oil, gasoline, diesel, combustion engine, and the car. And every time we changed the energy carrier from hay to coal to oil, we increased the energy density. We also changed the energy converter, increasing the power to weight ratio and the efficiency, and also changing the means of transport. Now, in the very first time, we go from gasoline, 12 kilowatt hours per kilogram, to battery, 0.2 kilowatt hours per kilogram. So it's a 1 to 50 energy density ratio decrease, which cannot be compensated by electric motors, which are about 5 times more efficient than a combustion engine. Now we are keeping with electric cars, and I've been in the automotive industry for 25 years. I think that once we change the energy carrier and the energy converter, we also have to change the means of transport, which means we're going into the third dimension. And yes, hydrogen fuel cell is going to be a crucial role. As I said, I've been 20 years in the automotive industry, did research. Mercedes-Benz said that they are going to get hydrogen cars in series production in 2001. That's 23 years ago. Fuel cells increased. Cost did not come down the way it was supposed to be. Hydrogen is going to be a future, but it's going to stay in the future for a couple more years or probably even decades. So I think it's going to be rather battery electric for the next 10 to 15 years at least. So you have to try to adapt to the new consequences concerning the very low energy density of batteries, and they are going to stay at approximately 250 watt hours per kilogram in the system. So try to get the weight down, try to make it as efficient as possible, and you'll be fine.
Thank you so much. Brilliantly said. Any further comments? Just because we have run out of time, but you can give us one last comment.
I can say only that we are working with companies on all these kind of propulsion. What I see very practical today is hybrid electric. But it's really worth to go on investing in new ideas, because we cannot stop exploring, and this is also one of the beauty of working with startups.
Thanks so much, Jürgen, Eric, Paolo. What a great pleasure. Thank you so much for those excellent updates, giving us that unique insight into vertiports and all the infrastructure around it. Thank you so much. Let's hear it for our panel. Thank you.